Hello everyone, welcome you all at Lokesh Sir Unlimited Study Zone. So we're starting our next chapter, that is wave optics. So previously in the previous chapter we have studied the ray optics. So what is the difference between ray optics and wave optics? As I said, optics having two branches. One is ray optics and second is wave optics. So ray, when a light ray comes from some source, as we are talking about light ray, so we have only three type of radiation that is emitted from the sun. First is very higher, very less frequency. One is first is infrared, second is visible, and third one is ultraviolet radiation. Okay. So for the case of optics, visible radiation is the radiation that is giving us sensation to see anything. So like a visible wave, what I'm saying, visible wave. So visible wave is emitted from the source and it's come on the surface of earth. Like this is a electromagnetic wave. Okay, so wave is a electromagnetic wave, transverse wave. It travels in the form of crust and trough, and so it incidented at some point P. Clear or not clear? So this is a visible wave here, and the direction of propagation of wave is called a ray. So this becomes visible ray, visible ray. So till now we have studied the path of the ray. Hmm. Till now we have studied the path of ray. Okay, path of ray. So this is the path of the ray. Clear? This is wave, and initial to final position in which direction your wave is moving is called ray. Clear? Hmm. So we have studied, yet now we have covered ray optics. Means we have studied about the direction of motion of a wave. Direction of motion of a wave is called a ray. But now we have to study the pattern in which the wave is traveling. Okay. So we have to discuss about this disturbance, movement of this disturbance in the medium, movement of disturbance in the medium. Okay. And transfer of energy, in which way the energy is transferred from one point to another point, and what are the other likely phenomenons related to the wave nature of a light. Clear or not clear? Okay. So this all study comes under the topic wave optics. Okay. Simply it means light as a wave. Light as a wave. Clear or not clear? Now, is in coming chapter I will deal with in that photoelectric effect and all, light as a particle, as a particle. Okay. And when we mix up both character, light as a wave and light as a particle, okay, like so from very long times there are so many large arguments between the different grid scientists that whether the light is work as a wave or it is working as a particle. So finally they agreed that light behave as both, as a wave and a particle. This concept is given by the great physicist de Broglie. Clear? De Broglie. And de Broglie given the dual nature, that is called dual nature of light. Okay, light. So he said that the a light radiation, a light energy behaves as both light energy or called radiation behaves as both wave as well as particle. Clear or not clear? So this is called the dual theory. After the completion of this chapter, we will discuss it also. So wave optics. Now, question is why we cannot realize the wave optics. So we in our daily life we can feel ray optics like reflection of light, refraction of light. This can be we have seen the phenomenon related to day-to-day life of reflection and reflection and cleared it with the concept of ray optics. But when wave optics is persisted, okay, The persistence of wave optics is only one condition. Now, condition for ray optics. You know, when ray optics is persisted, when size of obstacle, this is very important, size of obstacle or size of any anybody that is poses the opposes the propagation of light. Yes. So when the size of obstacle is greater than size of light, size of light, clear? When the size of obstacle is greater than size of light, and what does it mean size of light? It means wavelength of light, because the light having the size is denoted as its wavelength, clear? So when the size of obstacle is greater than size of light, it means its wavelength. Then you say ray optics will be persist there. Clear? So only the condition the size of obstacle is greater than the size of light or wavelength of light, you can visualize ray optics. But for the visualization of wave optics, it is compulsory that size of obstacle is less than, otherwise it is nearly equal to size of light. Clear? Light. So students, as size of light is very small. It is like 4,000 angstrom to 7,000 angstrom. This is the wavelength of light. It is varying from 4,000 angstrom to 7,000 angstrom. That is quite less. Okay. It is called 4 nanometer to 7 nanometer. Right? That is very less. Wavelength is very less. So the obstacle should have a lesser size than its wavelength. So in our daily to daily life, the objects, the practical objects are very larger, so we cannot realize wave optics. Clear? Yes. So wave optics we have to see in special cases, special conditions. So what is wave optics? Wave optics describe the connection between wave and ray of light. Yes, so far we have studied only the ray of light. What is ray of light? Ray is the direction of a wave. Ray, right anywhere. What is ray? Ray is the direction of a wave. Direction of a wave. Clear or not clear? And wave, it means disturbance. The propagation of disturbance is called a wave. Yes. What is wave? Propagation of disturbance, or it is called energy. Okay. This disturbance carry energy. See how, like there is a some place that is top, and there is some river at the bottom of this place. Clear? You have thrown a stone there at the bottom somewhere on the pond or lake. So there is a disturbance. What you created here? You have created a jerk here. Okay, there is a jerk. There is a disturbance. Now see, this disturbance will move with equal speed in all possible direction in a water. Yes or no? This disturbance will move in all possible direction. Means there are the particle, they are having same phase, they are moving in same phase, same time lag, and same distance, and with the moving with the same pattern. So if you join them, you will have a packet like structure, and this is called your first wave. Yes or no? In physics it is called wave front. Okay, it is called wave front. What, no, what does it mean? What is the name of this packet? This is called locus. Okay, locus. Yes, locus means if there are too many particles, if you join these particles, you have a trace, you have a curve. Okay, and this curve in which particles are moving, this is called locus. Clear or not clear? Hmm. So this is a locus, and in the same way, this disturbance is continuously moving in that medium. Yes or no? So what is the exact direction of this motion of this disturbance? So these are the ray, these repellings, these rings are called a wave. Okay, this is called movement of the disturbance, and the direction of the wave, this is called a ray. Clear or not clear? Yes, so this is ray. Okay, so in the direction of ray, the wave will travel. The disturbance will propagate in the direction of ray, and it is always perpendicular to the direction of wavefront. So write this line: ray is always perpendicular to the wavefront. Yes, ray is always perpendicular to wavefront. Clear or not? It is always perpendicular to the wavefront. So ray is always perpendicular to the wavefront. Done. Got it? Disturbance. Yes. Wave is the propagation of disturbance from a medium. Okay. When a disturbance is propagating, so the style of propagation is called a wave. Okay. And the direction of propagation is called a ray. Clear? So when you have to study the ray, it means you have to study about the direction of propagation. But when you study about the wave, this means you have to study the type of propagation. Okay, the type of propagation, not the direction of propagation. In which way the particle is vibrating, particle wave is traveling. Okay, yes. Mhm. So wave optics describe the connection between waves and ray of a light. So you see somehow the waves and ray of light are connected. These are the waves and these are the ray of light. Similarly, in um our when the light luminous object are there illuminating, like a bulb is there. Okay, and this bulb is illuminating. Clear or not clear? So this bulb emitting the light rays. Okay, and light rays are going like this in a spherical way. Okay, and the waves are forming a spherical wave fronts. So here these wave fronts, like we have formed in the river or pond. So these are called spherical wave fronts. So we have to study also the relation between what are these? These are called waves and these are called rays. So we also have to study the relation between the waves and rays. Clear? Wave optics describe the connection between the wave and ray of a light. According to the wave theory of light, a light is the form of energy, okay, which travels. So what is wave? It is the traveling of energy. Energy means disturbance. According to the wave theory of light, a light is the form of energy that travels through a medium in the form of transverse motion. Yes. According to the wave theory of light, a light is a form of energy which travels through a medium in the form of transverse wave motion. Obviously, we know the light wave is an electromagnetic signal, so that is moving by the vibration of electric field and magnetic field, and light wave is a transverse wave. Clear? The speed of the light in a medium depends on the nature of the medium. Yes, in air or vacuum, the speed of light, from the sun where the light is emitted, the speed of the light is c, because there is absolutely vacuum, 3 into 10 to the power 8 meter per second. But when it intervene to some medium from rarer to denser, we know that speed of the light changes reciprocal to the refractive index of the medium. Clear or not clear? So as the speed of the light changes, this means the speed of the wave connected to it also changes, because we have studied ray. This was the speed of ray. Okay, clear? Similarly, when the speed of ray changes, so the speed of the wave connected with that ray is should also changes. Clear or not clear? Here the speed of ray as well as the speed of wave equals to speed of light in vacuum, that is equals to 3 into 10 to the power meter per 3 into 10 power 8 meter per second. Clear? But in the medium, the speed of the light changes. The speed of the light in a medium depends on the nature of the medium. Okay. Now, the study of Actually, the study of light started with the Newton's corpuscular theory of light. You know, the era of 16th century, during the 16th century, has given his Newton had given his three wonderful law of gravitation and laws of motion. Okay, Newton's first law, second law, and third law. Clear? So in that time, Newton is like a boss of physics. Okay, so he proposed the corpuscular theory of light. Okay, because first there is a question about the existence of light, that a light is coming from the sun, having which nature. So Newton suggested the nature of light, and it is called Newton's corpuscular theory of light. Okay, so Newton's theory is called Newton's corpuscular theories of light. So this is 1675 AD, means mm, like l- almost approx 400 years from now. Okay, 400 years from now, Newton suggested a theory. So what he said that Newton proposed this theory. According to him, light consists of tiny particles called corpuscles, which are emitted by the luminous object. He said every luminous object emitted a very small particles of light. These are called corpuscles. Means light consists of very small particle. These particles are called corpuscles. Clear? Okay. Instead of some other name, he named these particles as corpuscles. Corpuscles means particle. Clear? These corpuscles travel with the speed of light in all direction. Yes, these corpuscles from the light source, if this is light source, so these light sources, from this light source, these corpuscles travel in all direction in a 3D way, right? The corpuscles carry energy and momentum. Yes, they carry energy as well as momentum with them. When they strike retina of the eye, they produce a sensation of vision. So these corpuscles carry energy and momentum, and when they strike on retina, they produce sensation of vision. Okay, later on you will study, yes, these corpuscles carry energy, but they don't have any momentum. Clear? Because they don't have any mass. The corpuscles of different color are of different sizes. Red color corpuscles are larger than blue colored corpuscles. So corpuscles of different color and different sizes. Red color corpuscles are larger than blue colored corpuscles. This theory could explain the reflection, refraction, and rectilinear propagation of light. Yes, this was the limitation of Newton's corpuscles theory, because this theory can only explain the reflection, the refraction, and rectilinear propagation of light. This means, what is reflection? Like these corpuscles are striking on the surface here, so they reflected back into the same medium. These are the this is the process of reflection. Clear or not clear? Now, if they incidented upon the some medium, transparent medium, they having some angle and move to the another medium. And rectilinear propagations, what does it mean, rectilinear propagation? It is the combination of so many type of linear motion. So combination of linear motion is called rectilinear propagation. Clear? Mm. So during the Newton's corpuscles theory, a light performing rectilinear propagation, a wave performing rectilinear propagation. The corpuscles theory could not explain interference, diffraction, and polarization of light. Yes. Approx 50 to 60 years, there is no one that can defend in front of Newton. Okay. And everyone consider this one, everyone accept this one, that light nature, light having made up of corpuscles. Clear or not clear? Okay. But a young scientist there, the name of that scientist is Thomas Young. Thomas Young. He performs experiment, few experiment, and the name of these experiment and some optical phenomenon, some wave phenomenon are there with the name interference. Okay, interference, diffraction, diffraction. So these two phenomenons, young scientist Young has performed, and these two phenomenons he has carried out taking the help of wave theory. Yes, with the help of wave theory. Okay, and Newton cannot explain these phenomenons with the help of particle theory or corpuscles theory. Clear or not clear? So the corpuscular theory could not explain interference, diffraction, and polarization. Yes, the corpuscular theory of Newton was unsuccessful to explain these wave phenomena. These are very important wave phenomena: interference, diffraction, and polarization. Speed of light in dense medium is more than speed of light in rarer medium. Speed of light in denser medium is more than speed of light in a rarer medium, according to his theory, which is incorrect. Therefore, the Newton's corpuscular theories were wrong. Yes. So, according to the Newton, in the denser medium, speed of light will be greater. But we know V is inversely proportional to mu. As medium increases, the speed of light will be decreases. Yes or no? As the refractive index of the medium increases, then speed of the light will be decreases. Clear? But Newton suggested just opposite of it. He said that in denser medium, the speed of the light will be greater than speed of the light in rarer medium. Clear or not clear? So this is just opposite to the truth. So speed of light in denser medium is more than the speed of light in the rarer medium. According to this theory, which is incorrect, therefore the Newton corpuscular theory is wrong. Okay. So after the Thomas Young experiment, Newton accepted his fault, and he taken back his theory and suggested that uh, light is behaved like a wave. Okay, means light follows the wave nature. Now, so in the direction of establishment of the wave nature, we have to study first Huygens wave theory. Yes. Mm. Okay. In 1675, in 1675, Newton given his corpuscular theory, and in 1678, after the 3 years of Newton's corpuscular theory, Huygens proposed his wave theory. Clear? But even after presenting his wave theory, so long years, peoples are not ready to accept Huygens wave principle. Clear? Till Thomas Young has not invented. You will see after Thomas Young, after the coming of Thomas Young, the wave theory of the light will established. Okay, has established. Clear? So in 1678, a Dutch scientist, okay, a Dutch scientist Christian Huygens, give wave theory of light. According to him, a light travels in the form of wave. Light does not travel in the form of ray. Actually, direction of light is a ray, but light travels in the form of a wave. Clear? Light travels in the form of a wave. He said, the Newton said that light travels in a straight line. Light travels in the form of corpuscles, means it is made up of particle. So when so many particle of joins, then there will a beam of light. There is a ray of light. Okay. So that was incorrect. Light travels in the form of waves. These wave travels in all direction with the velocity of light. Yes. These wave travels in all the direction with the velocity of light. Like so same thing that was told by the corpuscles. These corpuscles travel with the speed of light in all direction, but in the place of corpuscles there is a wave. Okay, these wave travels in all the directions, means waves means transfer of energy taken place in all the direction with the velocity of light. The waves of light different color having different wavelength. Yes. So these waves of light having different color. You know, light is made up of the seven color. Already Newton have given the concept of seven color by spreading the light of prism. So he said that light having Christian Huygens said that light is made up of the different color, and different color having different wavelength. Clear? The waves of light having different color have different wavelengths. Yes. Initially, the light waves were assumed to be longitudinal, but later, while explaining the phenomenon of polarization, the light wave considered to be transverse. Yes, initially the light waves was considered as longitudinal. Yes, means what are longitudinal wave? Longitudinal means the wave having the direction of vibration and direction of propagations are same. Like in a sound wave, particle of medium vibrating in this direction, okay, in forward direction, and the wave is also moving in the same direction. So this is called longitudinal wave. Clear or not clear? But later on, after the discovery of electromagnetic wave, it was established that light is an electromagnetic signal that is made up of the vibration of two mutually perpendicular field E and B. So when the two signals, electric field and magnetic field, vibrating perpendicular to each other, like this is magnetic field, this is magnetic field, perpendicularly vibrating in on along y-axis, and this is z-axis, and along the z-axis there is electric field is vibrating simultaneously with the magnetic field. So by perpendicular vibrations of these two fields in the direction both in the direction along x-axis perpendicular to both the magnetic field and electric field, there is a wave is called electromagnetic wave. So later on it was discovered that the direction of electromagnetic wave is perpendicular to the direction of vibration. You see, the direction of propagation is x-axis and the direction of vibration is y-axis and z-axis, that is perpendicular to both of them. Clear? So it was established that the light is transverse nature here. Huygens theory could not explain the reflection, refraction, interference, diffraction, polarization, but could no explain. Yes, wait, this is wrong here. Huygens theory could explain reflection, refraction, interference, diffraction, and polarization. So, with the help of Huygens theory, reflection, refraction, interference, diffraction, and polarization. Okay. So these wave events can be satisfactorily shown by the Huygens theory or Huygens wave theory, but Huygens fails to show the event of photoelectric effect and Compton effect. Okay, photoelectric effect and Compton effect. You know, students, actually, photoelectric effect and Compton effect are the those two phenomena of light. Those require the particle nature of light. Yes, these theories, these two phenomena of light can only be shown by the particle nature of light. Okay. So to satisfy the photoelectric effect and the Compton effect, light should have particle nature. So these two theories cannot satisfied by the Huygens theory. Obviously, in the 19th century, later, very later, like after 300 years later, clear? Scientist Max Planck, okay, Max Planck given particle theory, and that theory was named as quantum theory. Okay, in next chapter we will study the quantum theory of light. Clear? So Max Planck established the quantum theory. So again there is a rivalry between the two front. One is for the wave theory and another one is for the quantum theory. Then after, at the end of 19th century, a scientist with the name D. Broglie comes and he established the relation between both the theories, and he said that don't fight people, gentlemen. Okay, actually both the natures are working here for the light. Okay, when you see the wave theory, the quantum theory becomes invisible, and when you're talking about quantum theory, forget about wave theory. Clear? Yes. So many advancements are there in the field of wave theory and quantum theory. Okay, slowly we will study them. Wave theory introduce the concept of wavefront. Okay, so here, from here the wave theory start. First, it is the concept of wavefront. So Huygens introduced the concept of wavefront. In fact, the name of wavefront is uh, given by Huygens. Note, whole universe with all matter and space is filled with a illumina- illumiferous medium called ether of low density and very high elasticity. Actually, this medium ether is given by the name this is given by Newton. Corpuscular theory. During the suggestion of corpuscular theory, Newton given the medium of universe, he called it ether. Okay, Newton given the name ether. So, but that is not of any use now. Actually, we have to study only the wave theory of light. So, first concept is of Huygens principle. So, Huygens introduced the concept of wavefront. So, what is wavefront? You see here the first disturbance, clear or not, at the center. Clear? Now, this disturbance will transmit the energy. Yeah, this point, the first point that has taken the initial jerk, is transmit the jerk in all possible direction in nearby surrounding. Yes or no? Understood? It transmitted the energy to its medium, neighboring medium, in all possible direction with the same speed, with the same time. Clear or not clear? So there may be so many particles in the medium surrounding to that source of disturbance. Yes, this. These all the particle. Now tell me, these particle are dancing in a same manner or different manner? These particle are dancing in a same manner or different manner? Exactly. As the disturbance reaching at the same time, at the same distance, so they all have to dance in a same manner. Yes or no? So they have to vibrate in a same manner, and this same manner is called same phase in physics. Clear or not clear? Same phase. Phase means angle. Means if one particle has lifted his right hand towards here, another particle is also have to lifted his hand like this. Clear? Group dance, like a group dance. Okay. So a wavefront is defined as the continuous locus of all the particle. Yes, what is locus? Collect these point vibrating in the same phase, and you will have a path of the particle. Yes or no? This visible path is called wavefront. This visible path is called wavefront. Clear? So what is wavefront? A wavefront is defined as a continuous, means without breakable. Okay, without any break. Locus means cover something jacket like structure of all the particle. Locus of what? All the particle of a medium which are vibrating in the same phase is called, what it is called wavefront. Clear or not clear? Clear or not clear? Now, you see the wavefront I'm showing you. First, the wavefront just nearby the disturbance, it having the maximum displacement. Yes or no? Particles are looking somewhat upward. Yes, looking or not? See here, the particles are looking somewhat upward. Means this is the position of higher displacement. Yes or no? Yes. So this is the position of higher displacement. This is called crust. This is called what? Crust. Clear? Higher displacement position. This is called crust. After then, there is some suppression is seen. Yes. So this is called trough. Okay. This is called what? Trough. Okay. Then trough. Then again it is crust. Again heavy displacement or amplitude is maximum. Okay. Again heavy displacement is seen there. So again this is crust. So first it is crust, then it is trough, again it is crust. Okay. Then after then again it is trough. Yes or no? So this is crust, then again crust, then again trough, crust, trough, crust, trough, crust, trough. Clear? So light is moving in the form of crust and trough. Obviously, that is the feature of electromagnetic wave and transverse wave. In class 11th, we have studied that the waves moving in the form of crust and trough are called transverse wave. Clear, beta? So now, so of this jacket of the particle performing of the particle performing in the same phase is called wavefront. Clear? Hmm. So type of wavefronts, there are type of wavefront are spherical wavefront, cylindrical wavefront and plane wavefront. Okay, three types of wavefront is spherical wavefront, cylindrical wavefront and plane wavefront. Like there is some bulb in your home, like a bulb in your home. Okay, if this bulb is illuminated, then the light rays are going like this. Yes or no? These are the rays of light. Clear? So the particle are vibrating in the same phase is looking like this. So these patterns are called wavefront. Clear or not clear? So these patterns are called wave. So all these patterns, these rings are called wavefront. And what is ray? This ray. This is the direction of propagation of wavefront is called ray. Clear? Remember the particle here, if the particle is moved towards here, the disturbance, not particle cannot move. Particle can only perform vibration. Okay. It can give the vibration to its neighboring particle and neighboring particle will take the energy. In any wave, the particle mass cannot be travel. Only energy is transferred. Clear? Like there is a huge queue in a post office and you are here. So when someone pushes you, so the vibration, total vibration travels up to here. Clear or not clear? But you cannot leave your position. You can only jerk, you can only shake yourself, but your position will be there. Yes or no? So this is the transmission of wave. Okay, particle cannot leave its position. So this is ray, and from here to here, from here to here, the disturbance will travel in the same time and with the same speed. Clear or not clear? What I said, the disturbance will travel in the same time and with the same speed. Okay. Yes. Spherical wavefront. So three types of wavefront are there: spherical wavefront, symmetric, cylindrical wavefront, and plane wavefront. Remember, rays of light is always perpendicular to the rays. Rays of light is always perpendicular to the wave or wavefront. Yes. What is spherical wavefront? When there is a point source, like your bulb. So when there is a point source, then the wavefront formed surrounding a point source is called a spherical wavefront. So when a source is a light as a point source, the wavefront is spherical. Remember, amplitude A. Yes, amplitude A. Amplitude means maximum vibration is inversely proportional to the radius. Means maximum the distance, less will be the amplitude of the light. Obviously, as you move the large distances, you see the light amplitude of light will be less. Yes or no? There will be less amount of light. Clear or not clear? And if you move towards the light source, you will have a um, maximum amplitude. Clear? So make a first point. For a spherical source, A is inversely proportional to R and intensity is proportional to amplitude square. Intensity. What is intensity? Intensity means energy per unit area per unit second. This is energy. Clear? Okay. Intensity equals to energy per unit area per unit second. So amplitude is inversely proportional to R. Now see the wavefront. Here is the source. Okay. Here is what? This is the source. Now source emitting the light rays. These are the light rays and this is wavefront. This is your source. Clear? The first wavefront just after the source is called primary wavefront. Clear or not clear? The first wavefront is called primary wavefront. How it is formed? Like a disturbance will travel here. So these are the particles moving in the same phase, vibrating in the same phase. Clear or not clear? These particle, yes, now these particle becomes the fresh source of the further movement of energy. Yes or no? Say yes or no. These particles become fresh source. Why? Because the disturbance traveled to here. Okay. So now when the disturbance travel to here, these particles work as the fresh source of energy. Clear? So these particles vibrating in the same phase are called wavelets. what are called wavelets. Okay, so this is called wavelets. So these particle moving in the same phase, these particle are called wavelets. And when you join these wavelets, so you have a locus, and this locus is called wavefront. So this first wavefront is called primary wavefront. Clear or not clear? Primary wavefront. Clear? So what happened? This is the source, and this source emitted the disturbance. Okay, and the disturbance vibrating the particle of the medium in the same phase, and these particle behave like a fresh source of energy, and if you join these particle, you will have a wavefront. This is called primary wavefront. Clear or not clear? Primary wavefront. Now, as you know, these particle, now they behaving as a fresh source. These are wavelets. Clear or not clear? So as they behave as a source, they will emit the disturbance in same direction. Clear or not? Disturbance in all possible direction. Yes or no? They will emit the disturbance because they now they become source. So they will emit the disturbance in all possible direction. Clear or not? As they become the source. So like disturbance is traveled up to here. Here the disturbance is traveled up to here. Here the disturbance is traveled up to here. Previously, these are the wavelets, but now they have created some more wavelets. Now these are the wavelets, and all these particles, all these wavelets are the particle having vibrating in same phase. Yes or no? So again, you have to join these particles, and you will have a new locus. This is called secondary wavefront. Clear or not clear? So you can understand now in which way the wave travels through the medium. Okay. So first the central particle is a source, then it transmits its energy here. Then after it transmits its energy here, so the creation of the new wavelets. So this is first wavelet and then it is second wavelets. Clear? Joining the wavelets, you having the secondary wavefront. Clear? Any problem? Yes. So student, this is the way how the light is propagating in the medium. Light waves are propagating in the medium. Now talking about cylindrical wavefront, when a source of light is linear, yes, like you have a tube light in your home, there is a tube light. Consider, feel it about the tube light in your home. So this tube light having the very small sources, you can consider there is a small sources of light. Yes or no? And they emit the radiations in all possible direction. So if you join the radiations from all possible direction, you will have a cylinder. Say yes or no? Cylinder. So many rings are there. So if you join rings to rings to rings to rings to rings, so you will have a cylinder. Clear? So this is called cylindrical wavefront, and for the cylindrical wavefront, amplitude is inversely proportional to square root of r. R means distance, and intensity is inversely proportional to a square. Clear? Yes. So the ray is perpendicular to the wavefront. These are the wavefront, and these are the rays. Okay, rays will be moving like this. Rays is always perpendicular to the wavefront. Now, plane wavefront. When the source of light is very far away, like sun. Sun is a plane wavefront. Sun is a source of plane wavefront. How? Like these two rays. Okay, these are the two rays. Clear or not clear? Hmm. Now when you very distant away from these two rays, you are very distant away, like lakh, a million and trillion kilometer. When these rays reaches to the earth, now you see, if I taking the section of these two rays, yes, I am taking the section of this one part. Yes, I have taken this one. Yes, does these rays are looking nearly parallel? Yes or no? Yes, these are not parallel actually. Actually, they are emitting from the sun, but they are not parallel. But as the distance is very high, so for very high distances, these rays are appear to be parallel. Okay, and they form a plane wavefront because these rays are parallel. Yes, clear. And wavefront is always perpendicular to the rays. So this is called plane wavefront. Clear or not clear? So the sunlight we obtain is coming to us in a form of plane wavefront. Okay. Amplitude is constant for plane wavefront. Amplitude is constant. Clear. And intensity is also constant. It is not depending on r distance. So r to the power 0. Clear or not clear? Like in the presence of sun, doesn't matter you have stand on New Delhi or in Kerala, you will have the same intensity of light or different. Tell me, you will have same intensity or different intensity of light? Same intensity, exactly. So I is proportional to r to the power 0. Intensity is constant, means no dependence on radius or distance. Clear? Hmm. So now it is Huygens principle. We have to study the Huygens principle. So Huygens has given some statement that is called Huygens principle. So what is wavelet? A wavelet is the point of disturbance due to propagation of light. So point of disturbance due to propagation of light means when a disturbance traveled, it create further point of disturbance. So these point are called wavelets. Clear? And a wavefront is the locus of points, means these wavelets, those performing oscillation in same phase, vibration in same phase, okay, are called wavefront. The collection of these points is called wavefront. And the line perpendicular to the wavefront is called a ray. Now check here, the green point is a source. Like clear? So this is a source of disturbance. First, you have given your disturbance in a given medium or air or vacuum to this point. Now what happened? You check like this. So now these pink points are the freshly prepared source. Okay. So the particle vibrating in the same medium, first layer, the particle then after these first pink points transmits vibrations to the new position and another particle having performing their vibration in the same phase. Clear? Now join these all the points and you will have the wavefront. Clear? So after the source, first is primary wavefront, then secondary wavefront, then tertiary wavefront. Likewise, so many wavefronts are there. So this is a spherical wavefront from a point source. Clear? Now this is for cylindrical wavefront. A cylindrical source will be there and will give a cylindrical wavefront like this. These are the points wavelet of cylindrical wavefront. If you join, you will have a cylindrical wavefront. Clear? Cylindrical wavefront is emitted from the linear source. And this is plane wavefront. The plane sheets are called plane wavefront and the rays are perpendicular to these wavefronts. Clear? So pink dots are wavelet. The envelope, blue color envelope is called wavefront and red line is called a ray. Clear? Huygens construction or Huygens principle of secondary wavelet. What Huygens suggested about the construction of wavefront? Yes, this is the source. First source convey its vibration at the same distance on the same radius with the same speed and these fresh source are called wavelets. So these are called wavelets. The pink one are called wavelets. Clear? If you join these jackets, you will have a primary wavefront. Clear or not clear? You join these jacket, then you have a primary wavefront. So the blue one here is primary wavefront. Clear or not? Now the pink one, these dots, pink one dots are what? They are fresh source of vibrations. Yes or no? So they have transmit their own vibration like this. So they will prepare their own vibration and they will generate their own, they will create their own wavelets. Now join the wavelet having same phase. Yes, so these are the wavelet having same phases. See here, the upper one, here the upper one wavelets having the same phase vibration. Yes or no? So if you join these outer jacket, this becomes as a secondary wavefront. Clear or not clear? So this become primary, the inner one become primary wavefront, and this is called new wavefront, spherical wavefront or secondary wavefront. Clear or not clear? Now, Now consider this one source as a spherical source like a sun, and when you are very far away from this spherical source, and after so many times of this replications, this type of formation of wavefront at infinite, the point that these source, these curvature source become a linear source that I have shown you in that slide, that the part of spherical source become as a linear source. Yes or no? They are looking parallel. The rays coming from the infinite are becomes parallel. So these wavelets become in a straight line and they have a source like this. Now this is the formation of plane wavefront. Understood? For very distance, this wavefront becomes what? Plane wavefront. Clear? So red dots on the wavefront are called wavelets. Okay. So now what are Huygens construction principle? So write these principle. First, each point on the wavefront act as a fresh source of disturbance of light. Yes, each point, these wavelets are becomes the fresh source of disturbance of light and they create their own circles. Okay. So each point on a wavefront acts as a fresh source of disturbance of light. So they becomes as a source. The new wavefront at any time later is obtained by taking the forward envelope of the all secondary wavelet at that time. So these are the secondary wavelet here. Check my pointer. This is the secondary wavelet. This was the primary wavelet, and primary wavelet introduces the secondary wavelet here, here, here. If you cover it by forward jacket, you will have a locus of new wavefront. Clear? So the new wavefront at any time later is obtained by taking the forward envelope of all the secondary wavelet at that time. Got it? Yes. Backward wavefront is rejected. Yes. The backward wavefront, this dotted one is rejected because in coming derivation we will see the amplitude of the backward amplitude of the secondary wavelet is proportional to 1 upon 2, 1 plus cos theta. For backward envelope, theta is equals to 180 degree. So cos 180 degree equals to minus 1, and 1 and minus 1 is equals to 0. Okay. Actually, the amplitude of the secondary wavelet, okay, is proportional to half 1 plus cos theta. Clear? Yes, half of 1 plus cos theta. And for backward envelope, theta is equals to 180 degree. Clear? And cos 180 equals to minus 1. So 1 and minus 1 get cancel each other and you will have answer equals to 0. Means in amplitude is equals to 0. Clear? So for this backward envelope, amplitude is equals to 0. So it is almost invisible. So only forward envelope we have to take. Clear? Done? Okay, note it. Okay, yes. So Huygens principle, referring to this theory sheet, Huygens principle, every point on given wavefront called primary wavefront act as a fresh source of new disturbance called secondary wavelet. Every point on the given wavefront called primary wavefront acts as a fresh source of new disturbance called secondary wavelet. The secondary wavelet travels in all direction with the speed of light in the medium. What I said just before. A surface touching these secondary wavelet tangentially in the forward direction at any instant give the new secondary wavefront of that instant. Clear or not clear? Like see here, this is the your initial wavefront and these are the primary wavelets. Now these wavelets emitting their disturbance like this. This is the first one and this is the second one. Clear? Now these are the particle having vibrating in same phase. So if you join them, so the wavefront at a later time is tangent to all the wavelets. Done. Wavefront and Huygens principles is covered in today's class. Clear? Wavefront and Huygens principle.